Let's say that we wanted to take the indefinite integral of x squared times 3x minus 1 dx. Pause this video and see if you can evaluate this. So you might be saying, oh, well, what kind of fancy technique could I use? But you will see sometimes the fanciest, or maybe the least fancy, but the best technique is to just simplify this algebraically. So in this situation, what happens if we distribute this x squared? Well, then we're going to get a polynomial here within the integral. So this is going to be equal to the integral of x squared times 3x is 3x to the third. And then negative 1 times x squared is minus x squared. And then that times dx. And now this is pretty straightforward to evaluate. This is going to be equal to the antiderivative of x to the third is x to the fourth over 4. So this is going to be 3 times x to the fourth over 4. I could write it that way, or let me just write it. X to the fourth over 4. And then the antiderivative of x squared is x to the third over 3. So minus x to the third over 3. And this is an indefinite integral. There might be a constant there. So let me write that down. And we're done. The big takeaway is you just have to do a little bit of distribution to get a form where it's easy to evaluate the antiderivative. Let's do another example. Let's say that we want to take the indefinite integral of, it's going to be a hairy expression. So x to the third plus 3x squared minus 5, all of that over x squared dx. What would this be? Pause the video again and see if you can figure it out. So once again, your brain might want to try to do some fancy tricks or whatever else, but the main insight here is to realize that you could just simplify it algebraically. What happens if you just divide each of these terms by x squared? Well, then this thing is going to be equal to, put some parentheses here, x to the third divided by x squared is just going to be x. 3x squared divided by x squared is just 3. And then negative 5 divided by x squared, you could just write that as negative 5 times x to the negative 2 power. And so once again, we could just need to use the reverse power rule here to take the antiderivative. This is going to be, let's see, the antiderivative of x is x squared over 2, x squared over 2, plus the antiderivative of 3 would just be 3x. The antiderivative of negative 5x to the negative 2. So we would increment the exponent by 1, positive 1, and then divide by that value. So it would be negative 5x to the negative 1. We're adding 1 to negative 1. All of that divided by negative 1, which is the same, we could write it like that. Well, these two would just, you'd have minus, and then you're dividing by negative 1. So it's really just going, you can rewrite it like this, plus 5x to the negative 1. And you could take the derivative of this to verify that it would indeed give you that. And of course, we can't forget our plus c. Never forget that if you're taking an indefinite integral. All right, let's just do one more for good measure. Let's say we're taking the indefinite integral of the cube root of x to the fifth dx. Pause the video and see if you can evaluate this. Try to write it a little bit neater. X to the fifth dx. Pause the video and try to figure it out. So here the realization is, well, if you just rewrite all of this as one exponent, so this is equal to the indefinite integral of x to the fifth to the 1/3. I just rewrote the cube root as the 1/3 power dx, which is the same thing as the integral of x to the, if I raise something to a power and then raise that to a power, I can multiply those two exponents. That's just exponent properties. X to the 5/3 dx. Many of you might have just gone straight to this step right over here. And then once again, we just have to use the reverse power rule. This is going to be x to the, we increment this 5/3 by 1, or we can add 3/3 to it. So it's x to the 8/3. And then we divide by 8/3 or multiply by its reciprocal. So we could just say 3/8 times x to the 8/3, and of course we have our plus c. And verify this. If you use a power rule here, you'd have 8/3 times the 3/8 would just give you a coefficient of 1, and then you decrement this by 3/3, or 1, you get to 5/3, which is exactly what we originally had. So the big takeaway of this video, many times the most powerful integration technique is literally just algebraic simplification first.